Okay, we're going to go through what they call the fundamental identities. Really, this is, we go from right triangle trig. They really could have separated this into another chapter. It's like the author kind of switches gears right in the middle of this chapter. Okay, so this is on what they call the fundamental identities. And there are 8 of them, 8 fundamental identities. Okay. First, you need to know what a trig identity is. Definition-wise, trigonometric identity it is a trig equation, so that means it is going to have an equal sign in it. Okay. As soon as you see the word equation, it's a trig equation that is true okay, and mathematicians are lazy. Okay, the upside down A for all, you can read that for all or for any. Okay, the trig equation that is true for all values in the domain of its variable. Now, when they talk about the domain, those are the x values that work. Remember, like there would be some that would be not in the domain where, like for say cosecant, where you have those vertical asymptotes. Those x values would not be in the domain. Okay. Okay. I'm going to go through the 8 fundamental identities. And they break them down into reciprocal identities. And these you basically already know. The 3 reciprocal identities okay, the 3 reciprocal identities you already know, like cosecant. And they're going to use theta for their angle. On the calculator, it'll be x, but for what we're doing on paper, they're going to start using theta, alpha, beta. Remember, those are all on page 16 in your book. Cosecant of theta is a reciprocal with sine. Okay. Now, let's talk about that just for a minute. I'm going to give you one formula there, but there's actually 3 formulas written down. Okay. Cosecant is 1 over sine. What's another way to write that formula? Sine is equal to 1 over cosecant. What's another way to write that same formula? If you cross multiply, cosecant times sine, right? Because if we put that over 1, cosecant times sine equals 1. So when you see that one formula, it's written as one formula there, but you got to understand there's actually 3. Okay, sine is a reciprocal with cosecant, and sine times cosecant, reciprocals multiply together to give you 1. Okay, so that's one formula. Another one, secant. Secant's a reciprocal with what? Cosine. 1 over cosine. 1 divided by cosine of theta. Okay. And another way to say that same formula, cosine of theta is 1 over secant. Another way to say that is secant of theta times cosine of theta equals 1. Okay? And then the last one, last reciprocal, is cotangent of theta is 1 divided by tangent of theta. Okay? Okay, there's the reciprocal identities. Okay, then there are 2 ratio identities. Okay, and these will probably be new. The 2 ratio identities. Okay, first one is tangent. Tangent of theta is a ratio of sine over cosine. Sine of theta over cosine of theta. Tangent of theta is sine over cosine. The ratio is sine over cosine. Cotangent, if tangent is sine over cosine and cotangent's the reciprocal, then just invert that. So cotangent would be cosine over sine. Okay, cotangent of theta is cosine over sine. Okay, so that gives us 5. Okay, and the last 3 are Pythagorean. Okay, but the Pythagorean identities. Okay, and I'm going to go back to, let's go down here a minute. I'm going to go back to the line values that we did in the first chapter. Okay. In the line values that we did in quadrant 1, we said this was sine because, remember, we were in a unit circle, radius 1, and this was cosine. Okay, now in terms of that triangle, Pythagorean identity, you could say sine squared plus cosine squared equals 1 squared. Okay, so one of the Pythagorean identities is sine squared theta, and this is how you write it: sine squared theta plus cosine squared theta equals 1. Okay, in any right triangle, and it works. Because these are identities, it works for every angle that is in the domain. That's true for every angle that's in the domain. Okay, then we did, from this point, this was tangent. Okay, and this is 1 because it's the radius of the circle. What always touched with tangent? Secant. Right, so this was secant of theta. Now look at the large triangle. Look at this big triangle. Pythagorean. Okay, 1 squared plus tangent squared equals secant squared. So they're going to write it 1 plus tangent squared theta equals secant squared theta. Okay, and that's the second Pythagorean identity. Okay, and this all works because we're in a unit circle that's a radius of 1. Okay, what always touched up here? Cotangent, and it goes to the right. This is cotangent, and now this is 1. And what always touched with cotangent? Cosecant. So in terms of, now in terms of this triangle, this right triangle, okay, 1 squared, which would just be 1, plus cotangent squared theta equals cosecant squared theta. Okay, so that gives us the 8 fundamental identities. Okay. Okay, now we're going to stop there for a minute. Okay, I want to look at the page 133 on the homework. It says on the practice exercises down at the bottom, it says write 2 equivalent ways to express each identity. Okay, let's say I give you like look at number 3. Number 3 is tangent of theta equals sine over cosine. Okay. 3 is tangent of theta equals sine over cosine. Okay. Another way to write that, think of this as over 1. Now cross multiply. So if I cross multiply, I'm going to get sine of theta equals tangent of theta times cosine of theta. Okay, so I solved this equation for tangent. I solved this equation for sine. Now how can I get cosine by itself? Divide by tangent. So if I take this and divide by tangent, I'm going to get cosine on this side equals sine over tangent. So basically you've rewritten that formula. You're going to see one formula on your card, but it shows all three of them. Okay? Okay, go to number 9, page 134. It says verify each identity. Okay? On number 9, you need to take out your chart. Okay, look at the chart in your notebook that has the 30, 60, 90, 45, 45, 90. Okay, you need to look at that chart. Okay, on number 1 it says 1 plus cotangent squared of 30 degrees equals cosecant squared of 30 degrees. Okay, now on your chart, what is the cotangent of 30 equal to? Radical 3. So it's 1 plus. So we're going to sub in radical 3, but it's squared, cotangent squared. So it's radical 3 squared equals, look on your chart, what's cosecant of 30? 2. But it's squared. So they want you to verify that. So it's 1 plus, radical 3 squared would be 3. 2 squared would be 4. 4 equals 4. Checks. You verified it. So make a note, like on number 9, use your chart. That's like your 30, 60, 90, 45, 45, 90. Okay? On number 29, look at that for a minute. 29, same thing, verify each identity, use your chart. It says the sine of 45 times the cotangent of 45 equals the cosine of 45. So on your chart, what's the sine of 45? Radical 2 over 2 times cotangent of 45, 1, and cosine of 45, radical 2 over 2, yep, radical 2 over 2 equals radical 2 over 2, yeah, that checks. So you verified it. I guess I skipped one. Go back to number 19. I want to look at 19. 19, it says use the definitions. Okay, so on 19 they give you secant of theta equals 1 divided by cosine of theta. Now it says use definitions. You got to go all the way back to opposite, adjacent, hypotenuse. What's the definition of secant? Hypotenuse over adjacent, right? Equals 1 divided by, what's the definition of cosine? Yep, adjacent over hypotenuse. So if you take 1 divided by this, you're going to invert that fraction, and you're going to have hypotenuse over adjacent equals hypotenuse over adjacent. Okay, so when it says use the definition, like on 19 through 28, you go all the way back to opposite, adjacent, hypotenuse, and verify it that way. Okay?